Module 4. Confined Space Safety. Before entering a confined space, arrangements that are suitable and sufficient for the safety of persons must be in place. This module is intended to provide a detailed description of confined space safety measures and rescue. When you are ready, click Start Module to continue. Module Overview. Throughout this module, you will learn about rescue arrangements, means of communication, rescue training, safety and rescue equipment. This module's running time is expected to be about 25 minutes. Rescue arrangements. Whenever work in a confined space is carried out, arrangements that are suitable and sufficient for the rescue of persons in the event of an emergency therein must be in place. Where appropriate, the necessary equipment to enable rescue and resuscitation procedures to be carried out must be available. The arrangements must be in place before any person enters or commences work in that confined space. Rescue arrangements. The risk assessment will determine what emergency arrangements are necessary. The arrangements will depend on the nature of the confined space, the risks identified, and the types of emergency situations which are foreseeable. Account needs to be taken not only of possible emergencies arising by virtue of the enclosed nature of the confined space, but also of any other foreseeable accident which might make necessary a rescue operation. An example is the incapacitation of a person, wholly or partially, following a fall inside a confined space. Means of communication. An adequate communication system is needed to enable communication between people inside and outside the confined space, and to summon help in an emergency. When choosing a means of communication, consideration should be given to all anticipated conditions inside the confined space. For example, visibility, possibility of a flammable atmosphere, and noise levels, and to the personal protective equipment in use. Example, earmuffs and breathing apparatus. The communication system used can be based on speech, hand signals, telephone, radio, etc. Whatever system is used, it is important that all messages can be communicated easily, rapidly, and unambiguously between relevant people. The limited penetration of radio signals into buildings, vessels, and below-ground structures should be noted. Access and egress. A safe and convenient way in and out of the confined space should be provided for the individuals carrying out the work. Wherever possible, quick, unobstructed, and ready access and egress should be allowed. The means of escape must be suitable for use by every individual who enters the confined space so that he or she can quickly escape in an emergency. The size of openings used for access to and egress from confined spaces needs to be adequate to allow ready passage. Openings providing access need to be sufficiently large and free from obstruction to allow the passage of persons wearing the necessary protective clothing and equipment, and to allow adequate access for rescue purposes. These openings need to be kept clear whenever a confined space is occupied. Where practicable, an alternative opening should be used for insertion of hoses, ventilation ducts, power lines, and other cables required for the work. Rescue strategies. Possible confined space rescue strategies include the following. Self-rescue, where the circumstances, the nature of the hazards, and the control measures available allow. Rescue by trained team members using non-entry methods, if feasible. Rescue by trained team members using a safe entry technique. Rescue using a safe entry technique by the local public emergency services, subject to adequate time being available. This depends on the nature of the hazards and the response time of the emergency. Self-rescue strategy. Self-rescue is when an entrant is capable of recognizing a hazard and is able to exit from the space with no assistance. Many times, self-rescue involves the evacuation of a space when the entrant feels ill. In this situation, the assumption is that a hazard within the space is causing the problem, and that space evacuation is necessary until the problem is identified. Obviously, self-rescue has many advantages over the other two forms of rescue. With self-rescue, emergency rescue personnel do not have to enter the space. Risky extrication and/or removal techniques are not required if self-rescue can be employed. Also, by virtue of the fact that the individual is still conscious, the chances that the entrant will recover from the emergency are good. Hazard recognition can prevent serious exposure and injury. Self-rescue procedures. These procedures apply when the entrants or attendants determine that an unsafe situation exists or is developing. The entrants are physically and mentally capable of exiting the confined space on their own, and there are no obstructions to impede their efforts. Entrants must evacuate the confined space if the concentration of oxygen in the confined space goes below 19.5% or above 22.5%. Entrants must evacuate the confined space if the air sampling equipment alarm indicates that hazardous substance levels exceed safe levels. Entrants must immediately evacuate the confined space if they begin to feel or notice adverse health effects. The attendant or entrants should initiate evacuation if any ventilation equipment being used malfunctions. The confined space must be evacuated if any safety equipment malfunctions, a previously unidentified hazard is noted, or a potentially dangerous situation develops. There is a loss of communication with employees in the confined space. Non-entry rescue, as the name implies, is rescue performed from outside the space. Prior to entry, retrieval systems and body harnesses should be in place in the event that conditions change. In most cases, non-entry rescue involves removal using these lines. It's important to plan and conduct the entry with this form of rescue in mind. Pulley systems, tripods, and space entryways should be arranged so there is minimal chance for line entanglement. Non-entry rescue cannot be used for an individual who is entangled, trapped, or bound up within the space. It can be used for engulfment situations as long as the amount of engulfing material is small enough to allow the victim to be unearthed using line tension. In some cases, non-entry rescue is another name for body recovery. Individuals who are trapped in no-entry spaces or are in locations where the risk of entry far outweighs the gain may have to be removed. Non-entry procedures. These procedures define a process where the rescuer does not enter the confined space. Communicate with the injured entrant or another entrant in the space and identify the cause and nature of the injury. Extract the injured entrant from the space using the mechanical lifting equipment. If possible, maintain communications with the entrant while they are being extracted. Once the injured entrant is outside of the confined space, provide first aid as required. Ensure that they are comfortable and stay with them until the ambulance arrives. Do not allow anyone to re-enter the confined space until it has been confirmed that it is safe to do so. Entry strategy. Entry rescue is clearly the form of rescue that presents the greatest risk to the rescuer. It entails actually placing an individual into the hazardous space. Entry rescues should be avoided whenever possible. If entry rescue cannot be avoided, then SCBA, lifelines, harnesses, retrieval systems, and appropriate levels of protective clothing are required. Planning and communication are vital in entry rescue. Since an entry is being made, all safety check protocols must be performed, and an attendant will be required. If a change in the space is thought to have caused the emergency, appropriate testing and monitoring should be repeated. Entry procedures. These procedures must be followed when it is necessary for rescuers to enter the confined space to extract the entrant. Attempt to communicate with the entrants in the confined space to establish what injuries exist and what conditions exist that may impede the rescue efforts. Check the atmospheric conditions to determine if respirators or supplied oxygen are required. Confirm that all communication equipment is working. Ensure that an attendant is in place outside the entry point to assist the rescue team. Rescue team enters the space and provides any first aid that may be required to stabilize injured entrants. Prepare the entrant for extraction. This may require the use of stretchers, etc. Have the attendant operate the winching system to help remove the entrant from the confined space. Once outside the confined space, provide any additional first aid required to stabilize the entrant until an ambulance arrives. Rescue training. Any person who has a role to play in carrying out emergency arrangements must have received appropriate instruction and training to enable him or her to perform that role effectively. The level of training required, whether basic or advanced, formal or informal, will vary according to the complexity and skill content of the role. Refresher training should be provided as often as necessary to maintain an acceptable level of competence. Under no circumstances should the rescue arrangements be carried out by someone without training. The following table illustrates the roles required for every type of rescue. Take a moment to check it out. Safety logistics. When it comes to worker safety, it is important to consider the following characteristics of the confined space: internal configuration, elevation, portal size, space access. Internal configuration. Open. There are no obstacles, barriers, or obstructions within the space. One example of this is a water tank. Obstruction. The space contains some type of obstruction that a rescuer would need to maneuver. for example, a baffle or mixing blade. Large equipment, such as a ladder or scaffold, brought into the space for work purposes would be considered an obstruction if the positioning or size of the equipment would make rescue more difficult. Elevation. Elevated. A permit space where the entrance or opening is above ground by 1 meter or more. This type of space usually requires knowledge of high-angle rescue procedures because of the difficulty in packaging and transporting a victim to the ground from the space. Non-elevated. A permit space with the entrance located less than 1 meter above ground. This type of space will allow the rescue team to transport an injured worker normally. Portal size. Restricted. A portal of 60 centimeters or less in the smallest dimension. Portals of this size are too small to allow a rescuer to simply enter the space while using SCBA. The portal size is also too small to allow normal spinal immobilization of an injured worker. Unrestricted. The portal is greater than 60 centimeters in the smallest dimension. These portals allow relatively free movement into and out of the permit space. Space access. Horizontal. The portal is located on the side of the permit space. Use of retrieval lines could be difficult. Vertical. The portal is located on the top or bottom of the permit space. Rescuers must climb down or up the permit space respectively to enter it. Vertical portals may require knowledge of rope techniques or special patient packaging to safely retrieve a downed entrant. Rescue equipment. Rescue and emergency equipment needs to be suitable and sufficient to allow emergency arrangements to be carried out in a timely and safe manner. The equipment provided should be appropriate for the likely types of emergencies identified in the risk assessment and should be properly maintained. It should be readily available whenever and wherever confined space work is undertaken. Anchor and rigging systems. Anchors are means to secure ropes and equipment of the rescue system to something that is solid and will not fail under the stress of loading. Rigging is the system of rescue ropes and hardware attached to the anchor system. Anchors must be the strongest link within your system. Bomb-proof is a term for anchors strong enough to withstand any force the system may deliver to the anchor. Bomb-proof anchor rigging. A suspect anchor, or an anchor that may not be bomb-proof, should be backed up with a secondary anchor. However, the use of several weak anchor points is undesirable and should be avoided. If one anchor fails, the shock loading will lead to failure of all points. If a secondary anchor is needed, it should be as strong or stronger than the primary anchor. Good structural anchors include structural steel, davit arms, beams, stairwells, and heavy handrails. Bulk concrete anchors are found in supports, columns, and corner walls. Cast or insulated small diameter pipes, corroded metal, small diameter handrails, old brickwork, light metal supports, and vents are not bomb-proof anchors and should be avoided. Rigging cautions. Keep in mind the following. Do not run nylon over nylon rigging. Pad sharp edges, as any bend under 4:1 weakens the rope. Avoid hard linking, that is, 3 or more carabiners linked together. Double check by sight and touch. A pulley in rigging systems should always be backed up. Angles greater than 120 degrees cause extra load on anchors. Harnesses. The type of harness depends on whether the worker must be rescued in a vertical direction or otherwise. If the rescue is anything other than a vertical rescue, the qualified person will consider the equipment required. In a vertical rescue, a full-body harness must be used to keep the worker in an upright position. Safety harnesses with leg, waist, and shoulder straps must meet the requirements of CSA Standard CAN, CSA Z259-1, M90, full-body harnesses. Note: wrist harnesses attached to each wrist of the worker are designed only to help prevent contact of the arms with hazard points. Safety lines attached to wrist harnesses must not be used as rescue equipment. Lifelines and connections. Select lifelines for strength, chemical stability, abrasion resistance, and, where high voltage may be encountered, electrical resistance. For example, nylon has good breaking strength and abrasion resistance, but may not be a good choice around high voltages because of its ability to absorb moisture. Lines must be free of knots and splices, except at the ends, and must be securely anchored. Connections to harnesses should be made with locking snap hooks or a locking type carabiner. Lifting equipment. Lifting assist devices include the following: a worker-rated hand winch with a dog action brake or a block and tackle to provide mechanical assistance capable of both lifting and lower in. A powered winch capable of both lifting and lowering, and with an effective means of control that has been tested before use. Edge rollers to protect the lifeline from abrasion where the line encounters sharp edges. A rope grab, brake bar, or other similar device to help prevent return slippage. Rescue equipment. All equipment provided for the purpose of emergency arrangements should be properly maintained and inspected. Inspection should include periodic examination and testing as necessary. This shall be in accordance with the manufacturer's instructions or with the requirements of health and safety legislation as appropriate. This is the end of Module 4. Please exit the module window and proceed to the testing section.